Hi there. So today I'm going to be talking about basic derivatives and how we derive them. So once we derive them, adding them to our table of differentiation so we can use them in future examples. But honestly, how we derive them is not super important. But in this video, I'm just going to kind of go over like how we actually do, and it's good for problem solving to be able to follow what I'm doing. So hopefully it provides some use. Um, so the first one I'm going to talk about is y is the inverse sine of x. How can we figure out the derivative of this? So we know that if y is just sine x, right, we know the derivative of that is just going to be cosine x. But what happens when we're taking the inverse sine of x? Well, inverse sine of x really just means that x equals the regular sine of y. So we're essentially just switching x and y, because remember, inverse means switching x and y. So x equals the sine of y. Okay, so what we're going to do now is we're going to differentiate both sides. So the derivative of x with respect to x is just 1, right? Dx over dx. Sine of y, we're going to have to use a bit of implicit differentiation here. So we're going to have to go, the derivative of sine y is going to be cosine y. But remember, by the chain rule, we have to multiply by y prime. Okay, so this means if we want y prime on its own, it's going to be 1 over the cosine of y. Well, what is the cosine of y? Because we started with a function in terms of x, and now we have a function in terms of y. So we have to recall that sine squared, we'll go y, plus cos squared y is equal to 1. So this must mean that cosine y is equal to the square root of 1 minus sine squared y. Okay, so instead of cosine y, I'm going to write 1 over the square root of 1 minus sine squared y. And remember, x was equal to sine y. So instead of sine squared y, I can just write x squared, because sine squared is really just sine of y squared. And if sine of y is x, it's just x squared. Okay, and we can do the same thing with cosine and derive it the exact same way. So let's do that. Now with cosine, we're really saying x equals cosine of y. So if we differentiate both sides, we're going to get 1 equals negative sine y times y prime. So we're going to get y prime equals negative 1 over sine y. And this is the same kind of idea. Cosine y is going to be the square root of 1, or sorry, not cosine, sine y. That's going to be the square root of 1 minus cosine squared y. And remember, cosine's just going to be x, so it's going to be it's going to be 1, negative 1 over the square root of 1 minus x squared. So it's really the same as what we did before, just negative out in front, because when we differentiate the cosine y, we get a negative in front. Okay, now let's do tan to the negative 1. Same kind of idea. This means that x is going to be equal to the tan of y. We have to remember, if we differentiate both sides, 1 is going to be equal to, well, the derivative of tan, that's going to be secant x tan x, right? If I'm right, actually, I'm not completely sure. Let me just check. The derivative, oh, it's secant squared, that's my bad. So it's going to be secant squared y. Okay, so we differentiate the left and the right. And we have to remember that tan squared and secant squared are related, right? So secant squared of, let's say, y equals tan squared y plus 1. So if we have 1 equals tan squared y plus 1, right, because that's really what secant squared is equal to, we can replace tan of y with x, because we know x equals tan of y. So 1 is going to be equal to Oh, we also have to multiply this by y prime, my bad. What am I talking about here? So let me just kind of skip a step. So we have to multiply by y prime via the chain rule. So y prime is going to be equal to 1 over secant squared y. Lots of these inverse trig functions, it's like 1 over something squared. And instead of 1 over secant squared, we can just write 1 over 1 plus tan squared of y. And this is just 1 over 1 plus x squared. Okay? Because tan y really just is x. So tan of y squared is just x squared. Now let's talk about y equals x to the x. How can we find dy by dx? Well, this is called logarithmic differentiation. Anytime we have like a variable in the exponent, usually we're going to have to take the natural log of both sides. So the natural log of y equals the natural log of x to the x. Now remember our properties of logs. We can bring this x out in front, right? So if we do that, let me just change this. It's going to be x times the natural log of x ln x. Now if we differentiate both sides, right? If we differentiate both sides, we're going to get, well, we're actually going to have to use a product rule for this one. So it's going to be the derivative of x times ln x, right, plus the derivative of ln x times x. So the derivative of x with respect to x is 1 times ln x. Then we're going to be adding the derivative of ln x, which is 1 over x times x. So this is ln x plus 1. That's the derivative of x ln x. So just kind of an extra step there, but this is going to be, well, the derivative of ln y with respect to x is going to be 1 over y times y prime via the chain rule. That's going to be equal to ln x plus 1. Now remember, we're solving for y prime, so we have to multiply by y on both sides. Okay, so it's going to be y prime equals y times ln x plus 1. And I should kind of put brackets around it because the 1's not included in the logarithm. Okay, and remember, we have to remember that y was equal to x to the x. That's what we started with, right? Y was equal to x to the x. So that equals ln of x plus 1. And that's our answer. Okay, next one, ln x. I just mentioned it in the above one that the derivative was 1 over x. But how can we actually find that? Well, it's going to be the same thing. Okay, so let's write this in exponential form. Instead of saying y equals ln x, this is really the same thing as y equals log and base e of x. So this is really saying e to the power of y equals x, right? So if e to the power of y equals x, that means that we can differentiate both sides. So the derivative of e to the y with respect to x is going to be e to the y times y prime via the chain rule, and that is going to equal 1, right? Because the derivative of x with respect to x is 1. Now, we're going to have to divide by e to the y on both sides. So y prime is 1 over e to the y. And e to the y, remember, was equal to x, right? We just figured that out. So if we have 1 over e to the y equals x, that's going to be equal to 1 over x. Okay, and that's how we get our solution there. Okay, and I also just mentioned e to the derivative of e to the y with respect to y is going to be like e to the y itself, like d by dx of e to the x is e to the x. So let's prove that right now. Let's figure out what the derivative of some constant a to the power of x is. In the case of e to the x, the constant's e, so let's just take a look. If we have a to the x, let's try and figure this out. If we have y equals a to the x, how can we isolate for this? Well, one thing we can probably do is take the natural log of both sides. So honestly, I'm not completely sure how we can do this, but I'm going to work through it because I see an exponential. I see there's an x in the exponent. So I'm probably going to use the natural log. So this is going to be the same as x times the natural log of a. Okay. Now, what we have here is we're trying to get y prime. We don't have a y prime in our equation. So let's use implicit differentiation. Let's go the natural log of y with respect to x. So that's going to be 1 over y times y prime. And that's going to equal the derivative of this right side here. So the derivative of x times ln a, remember ln a is just a constant. So this is just ln a times the derivative of x, which is just 1. So the right side is just going to be ln a. Okay. Now if we have 1 over y times y prime and we just want y prime, we just got to multiply by y. So it's going to be ln a times y. And now that we have just times y on the right, y was equal to a to the x. So instead of y, let's just write a to the x. So the derivative of any expression a to the x, that's just going to be itself a to the x times the natural log of the base. Okay, so y is the derivative of e to the x equals e to the x. Why is that true? Well, if we use this formula we just figured out, the derivative of e to the x is going to equal the natural log of e times e to the x. Well, the natural log of e is just 1, because e to the power of 1 equals the argument e. So this is 1 times e to the x, which is just e to the x. So if our a, our constant, is e, we're just going to get e to the x for our derivative. Now let's do the last question here. Secant x. Well, y equals secant x, let's rewrite that in terms of cosine. So secant x is 1 over cosine x, or we can just write cosine x to the power of negative 1. It sucks we can't write cosine negative 1x because that's like the inverse cosine. The notation's pretty ridiculous, to be honest, but we just gotta live with it. So let's use our power rule. Okay, so y prime, just differentiate both sides. We're gonna use the power rule, bring the negative 1 out in front. It's gonna be negative. Then we're gonna take the derivative of cosine, or sorry, it's gonna be negative cosine x to the power of negative 1. Remember, we have to multiply, or not negative 1, negative 2. Whoops, so negative cosine x to the power of negative 2, we reduce that exponent by 1, times, via the chain rule, the derivative of the inside, which is cosine. Derivative of cosine is negative sine. So the negatives here are going to multiply and cancel. We're going to get sine x over cos squared x. And we can split that up into sine x over cos x times 1 over cos x. So this is going to be sine x over cos x is tan x times 1 over cos x is secant x. So the derivative of secant x is just itself times tan x. So there are 5 or 6, maybe even 7 examples that we did to kind of add to our table of derivatives. These are probably some of the most common ones, like ln x comes up probably every question. So that's a nice one to know. X to the x doesn't come up very much. A to the x, e to the x comes up a lot. Secant x, a little bit. But just knowing how to derive these derivatives, not just memorizing them, it gives you some intuition into like how mathematicians actually kind of induce and deducted all this information. So it's definitely cool things to know. If you could follow along, that's great. If not, you have your tables to fall back on, and I'll see you in my next video. Drop a comment if you have any questions, and yeah.